Welcome to our second pile actions tutorial video. In this video, we'll go through how to set up different pile types, loadings, and go through the results together. If you want to know more about setting up the ground profiles for analysis, please refer to our first pile actions tutorial. In this example, I've already set up two ground profiles for analysis, and I'm ready to set up my pile types. To define pile sections and properties, let's go to the Pile Types tab. When you go to the Pile Types tab, a default pile type is already available. We can define the from and to depths of the pile sections over here, and we can add more pile sections using the Add Sections button. This is useful when your pile has varying section properties, such as having a pile casing over a particular depth range. The pile properties can be defined for each section by clicking on the Edit button here. The section type can be chosen using this drop-down menu. Currently, we provide two types of pile sections, which are the elastic sections and the elastic perfectly plastic sections. I'll define the first section using the elastic section. The pile section properties can be defined using either ordinary notation or scientific notation. I'll define the second section using the elastic perfectly plastic section type. This section type also requires a moment capacity. If the moment in the pile reaches that capacity, the section will continue to deform without providing any additional resistance. The pile head fixity can also be defined. There are two types of pile head fixities, the translational fixity and the rotational fixity. Translational fixity provides a shear force to the pile head when the pile head moves laterally in either direction. It can be set to free, fixed, or restrained. When different head fixities are chosen, the graphical representation is also shown in the preview. When a pile head has the translational fixity set to free, the pile head is free to move laterally. No shear force will be provided at the pile head. When the pile head has the translational fixity set to fixed, the pile head is not allowed to move laterally. The fixed support provides the required shear force to keep the lateral displacement at the pile head zero. When the pile head translational fixity is set to restrained, you can define a spring with a constant stiffness attached to the pile head. When the pile head moves laterally, the force provided by the spring will be calculated based on the defined stiffness. Similarly, the rotational fixity can also be defined. Rotational fixity provides a bending moment to the pile head when the pile head rotates. It can be set to free, fixed, or restrained. When the pile head has the rotational fixity set to free, no bending moment will be provided at the pile head when the pile head rotates. When the pile head has the rotational fixity set to fixed, the pile head is not allowed to rotate. The fixed support provides the required bending moment to keep the pile head vertical. And lastly, when the pile head rotational fixity is set to restrained, you can define a rotational spring with a constant rotational stiffness attached to the pile head. When the pile head rotates, the bending moment provided by the spring will be calculated automatically based on the defined rotational stiffness and the pile head rotation. Pile grouping factors can also be defined. Grouping effects in the pile actions module is represented by the P multiplier and the Y multiplier. These multipliers are applied to the PY curves over the defined depth range. For example, if the P multiplier is set to 0.8, the P values of the PY curves over the depth range will be multiplied by 0.8, resulting in a 20% reduction in soil resistance at the same pile soil relative displacement. Multiple depth ranges can also be applied. Similar to ground profiles, multiple pile types can also be added. Click on Add to add a new pile type, or you can click on Duplicate to create a copy of the existing pile type to modify it. If you want to change the name of the pile type, click Settings and change the name. After all the pile types are defined, don't forget to click Save, and we're now ready to move on to the load definition in the Load Scenarios tab. There are two categories of loads. They can either be force-based loads or displacement-based loads. Force-based loads include point loads, distributed loads, axial loads, and applied moments. Displacement-based loads include applied pile displacements or applied soil displacements. We can also select static or cyclic analysis for a loading scenario. Note that this doesn't actually change the loads applied, it is only used to decide whether the static version or the cyclic version of the PY curves are used. This only applies to PY curve models that have different static springs and cyclic springs, such as the metal soft clay model or the stiff clay models. For this tutorial, I'll add a point load at 1 meter below the ground surface for loading scenario 1, and then I'll create a new loading scenario with an applied pile displacement, and I'll call it loading scenario 2. In this pile actions module, I have defined 2 ground profiles, 2 pile types, and 2 loading scenarios. In the Review tab, all possible combinations are presented, and I can select the cases I want for analysis. In this tutorial, I'll select all cases, save the module, and run the analysis in the Assessments tab. Once the analysis is done, click View Results to see the results of all analyzed cases. There are 3 Results tabs, and we'll go through the tabs one by one. The first tab is the Bending, Shear, and Displacements tab, where you can see the bending moment diagram, shear force diagram, and lateral displacement profiles of all analyzed cases. You can either select a single case to see the results, or select multiple cases for easy comparison. You can also click on the Preview button to visualize the loading and head fixity of a particular case in the Preview panel. Next, let's take a look at the PY Curves tab. The PY Curves tab shows all the PY curves used in analysis. Note that the PY curves can only be viewed case by case. And finally, we have the Top Deflection versus Maximum Actions tab. There are 3 graphs in this tab. The first one is the pile head lateral force versus pile head lateral displacements graph. This graph is essentially the pile top lateral spring. Note that this graph is direction sensitive. For more detail, check out our technical documentation. The second graph is the maximum bending moment versus pile head lateral displacement graph, which shows the maximum bending moment along the pile at different pile head displacements. The last graph is the maximum shear force versus pile head lateral displacement graph, which shows the maximum shear force along the pile at different pile head displacements. These graphs are handy when you want to quickly see whether the bending moment or shear force has exceeded a certain value. Again, these graphs in the third tab can also be viewed case by case or for multiple cases. You can export the results as Excel files in the Export tab. Select the cases and output you want to export, and click Export to download the output. This wraps up our second tutorial on pile actions. For more information, please check out our technical documentation, and if you have any questions, feel free to send us an email. Thank you.